Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good day to everybody. Hi, my name is Faiza bint Abdul Aziz. Today I would like to present a paper entitled Mobile Augmented Reality Application Improves Performance in Programmable Logic Controller Experiment. The paper ID is number 68. Okay, before I proceed, let me define first what is augmented reality and mixed reality. Okay, augmented reality is a powerful technique to enhance the existing reality by using technology to observe and create an environment that is beyond the human's eye perceive and feel while remaining in the real world, where mixed reality is the merging of real and virtual worlds to produce new environments and visualizations where physical and digital objects coexist and interact in real time. At the bottom left side, you can see an example of augmented reality, which is Pokemon Go. And on the right side, you can see the woman using Microsoft HoloLens 2 for mixed reality. All right, for the problem statement, we know that the difficulty in comprehending laboratory works among students has increased significantly due to the tedious procedures of the experiment. So besides that, students face difficulties to understand the procedures of the experiment, which lead to a longer period to complete the laboratory, and also this can increase the number of errors made during the experiment, which can contribute to poor work results. So for the work, we have 4 objectives. The first one is to develop an augmented reality application for PLC laboratory work using smartphone device. For objective number 2, we will develop a mixed reality application for PLC lab work using Microsoft HoloLens 2. And for the third one, we will evaluate the effectiveness using the developed AR application that we developed earlier. And number 4, which is to assess the understanding of mixed reality using Microsoft HoloLens 2. For this work, we've reviewed quite comprehensive papers. So we also touch the topic of marker-based, markerless AR, projection-based AR, and also superimposed augmented reality. Here you can see some of the figures. For example, like this, the utilization of AR application in components of computers, and here for markerless, we can use device like tablets or handphone. This is for projection-based AR, where we always use, for example, like to teach students, for example, like in geography class. And on the right side is the superimposed based AR. It's very good to teach or to explain to users about the, for example, like in the historical site education, where we can superimpose the information with the real world. Okay, for the mixed reality application, we also review several papers. For example, like the integrate virtual objects with real world. Those papers, we review that paper, and also we also studied about the live interaction and create the interaction between the real thing and the virtual objects by mapping between them. Alright, so let's move to the methodology. For the hardware, we use the mobile phone in developing the AR application. So we use Samsung Note 10, which has the variety of a feature that are suitable for AR application. The device can deliver a high quality AR viewing experience, providing maximum comfort to users. And then on the right side, you can see the Microsoft HoloLens 2. So we use this in developing the mixed reality application So the device is a head-mounted device, HMD, that specializes in mixed reality application, where it is equipped with see-through lenses, which can assist people in viewing holographic images. And then in the middle, you can see the PLC components which we required for paper-based experiment. Next, let's move on to the software that I use for this experiment. For 3D modeling, we use SolidWorks and Blender. And for the application development, we use Unity 3D, Vuforia, MRTK Toolkit, and also the C# scripting. We use 35 students from the Department of Mechanical and Manufacturing Engineering, University Putra Malaysia, to participate in this experiment. The questionnaire we set for 4 sections. Section A is the questions about the person's general knowledge of AR and PLC. For section B, it provides feedback questions for the participants after handling the experiment using paper-based instruction. For section C, inquires about the feedback of the participants using AR application. And for section D, provides the choice for participants in choosing the most preferable way to conduct the experiment. For the methodology, we take we conducted the analysis by taking data to perform the task completion time analysis and also the error counts as well as the number of hints. These are the overall project workflow activities. As you can see, this show it to you the overall, which obtain objective 1 here and objective 2 here, and the bottom part objective 3 and 4 to evaluate and to assess the developed apps that we created. I have another 2 flow chart to show it to you. This is the AR development workflow. Okay, and this is the MR development workflow. Okay, for the in developing the AR and developing augmented reality application and mixed reality application, we use the software like SolidWorks, Blender, and also the Unity 3D. Okay, so SolidWorks we use in modeling the 3D objects like power supply, connecting wires, and also switches, buzzers. We draw in a 3D format. And for the 3D models, have the dimension as the same as the real world object. So to make sure that it gives better user experience. Blender is used to make animated features, motion graphics, interactive 3D apps, and also the last one is the Unity 3D. As you can see here, the 3D models from SolidWorks are imported to Blender before the model is transferred to Unity 3D. Unity 3D is a game engine platform which provide interactive, and also they have the feature like a drag and drop capability. Then we test the apps. Okay, for the results, as you can see, this is the objective 1 results. We developed the AR application. These are the 3D drawing, and then we transfer, as I mentioned just now, we pass to the Blender and also Unity 3D to create the AR and MR features. So here we have the marker-based AR application. And then finally we deploy to the smartphone. Okay, next for the these are the procedures of the mobile AR application. We have several scenes. I just provide you with these scenes. For example, like these are the welcoming scenes, and this is just to show it to you the apparatus that we have. And the bottom part, you can see that we have the feature adding the buzzer, and also the audio feature is added here. This slide shows the user performing the AR application demo, where you can see this is the marker that he has to point. This is the results for objective 2, which is develop mixed reality application. As you can see, these are the process. You can see that in mixed reality we have the animation, we have the features of holographic. For example, like here you can see holographic wires, so that the user can perform the task by following the holographic images that they can see, right? Then we deploy to Microsoft HoloLens 2. Okay, so this is the results for the evaluation of the effectiveness of AR application, which is objective 3. You can see on the left side is this task completion time, and on the right side is the error counts. Okay, for the task completion time, the average task completion time, or TCT, for the students to complete the experiment using paper-based instruction is higher than using the AR-based instruction. And most of the participants that use paper-based instruction took a time that range approximately 3 to 23 minutes, as compared to the one using augmented reality is around 3 to 8 minutes. Okay, and then for the right side, which is the error counts, the average error counts that were made by the participants using AR is much lower. The participants were able to correctly connect the wires using the augmented reality based application, as the instructions of the applications were clear, and there were indications on how to connect the wires. Next is the results of POI, or percentage of improvement. To evaluate the performance, the percentage of improvement of TCT, or task completion time, error counts, and number of hints were calculated using the formula given. You can check in the paper that the formula that I included there in the paper. So the results showed that there are improvement for task completion time, and for error counts and number of hints, there are also improvement, because there are reduction in the error counts and reduction in number of hints. For error counts and number of hints, and also the task completion time, the lower the better. Yeah? These are the assessment for objective 4, where you can see that we managed to conduct a demo where user can see clearly the holographic wires, and these are the hand tracking features that we add to the mixed reality application. And here is the user is experimenting with PLC using MR application. And this is the front view of the HoloLens that we use. And this is the last slide of our conclusion, that we managed to develop AR and MR application. And these are the reference used for my slides. Thank you very much. And if you have any questions, please contact me. And if let's say you have any future collaboration, please contact me by this email. And these are the list of authors for this paper. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.